In question C, again, you should be scanning quickly for any greatest common factors, and there are any common factors of 64 and 125. Then go through your lens. It's a binomial, so I've got to be looking for the sum and difference of two cubes or the difference of two squares. So this looks like a pretty good candidate for the difference of two squares until I start looking at this part. 125 is not a perfect square, and anytime this is odd, it can't be a perfect square, so I know it's not the difference of two perfect squares, so then I should be looking at, is it the difference of two perfect cubes? And 64 is a perfect cube of 4, and as long as this power is divisible by 3, it'll be a perfect cube. And 125 is a perfect cube of 5, so I have the difference of two cubes. So the factorization pattern of the difference of two cubes is very similar to the factorization pattern of the sum of two cubes. You take the cube root of the first thing minus the cube root of the second thing, then you take it times the square of the first thing plus, the signs are always opposite, the first thing times the second thing plus the second thing squared, which is b squared. So this is the pattern that we're going to try to emulate. So we want to take the cube root of the first thing. Well, the cube root of 64 is 4, and the cube root of x to the 12th is x to the, all you got to do is divide that by 3, which is x to the 4th, because x to the 4th times x to the 4th times x to the 4th is x to the 4th cubed, which is x to the 12th. So just trying to explain that perfect cube in there. So then I take the perfect cube of 125, which is 5, and y to the 9th, we divide it by 3, so y to the 3rd. So there's my first factor in this pattern. I took the cube root of both the first thing and second thing. Now, to get my second part of this, I take the first thing and square it. That's going to be 4 times 4 is 16. X to the 4th times x to the 4th is x to the 8th. Then you multiply the first and the second thing together. Remember, the signs have to be opposite at this location and that location. So I want those to be opposite. So I just got rid of too much. Plus, and then we multiply the first thing and the second thing together, which is going to be 20, x to the 4th, y to the 3rd. And then we square the last thing, which is going to be 5y cubed squared, or 5 times 5 is 25, and y cubed is y to the 6th. Okay? So some things to remember here. Make sure that these signs are always opposite. These signs here are guaranteed to be positive because we are squaring them. So remember, this sign and this sign will always be positive, and the signs in the middle are opposite. So the sum of two cubes and the difference of two cubes, that's a new factorization pattern. Obviously, it's going to take more effort and time to remember that pattern. So I gave you a couple of examples of each so that you can go back and review those patterns.